is the lesson portion of adding and subtracting rational expressions. So we reviewed how to do this concept. It's a fifth, fourth grade concept of adding fractions, subtracting fractions. At the beginning of the unit, we also reviewed it right before this lesson. So we're going to do it within the lesson as well. So when you're adding and subtracting rationals, you absolutely, not when you're multiplying or dividing, but when you're adding and subtracting, you absolutely must have common denominators. And then you add or subtract the numerators, or the like terms in the numerators. You must always also simplify the rational that's left over, if possible. So for problem number 1, the denominator is the same. We have 3 on the bottom, it just slides over, and then I have 2 minus 1. This equals 1 over 3. All right, problem number 2, they are not the same, but you could either, you could do two things. Okay, you could simply do what I did before. If you can't see that 3 is a factor of 9, you could just say 9 over 9 times 2 over 3 plus 3 over 3, or 3 over 3 times 1 over 9. It produces the denominator here, the same denominator. We have 18 over 27 plus 3 over 27. This is 24 over 27. It simplifies to 8 over 9. Now that's one method, but if you can see that the bottom two denominators, that they are both, you're able to use a factor of 9 to get 3 to be 9. So what I mean is, instead of having to do all the extra work, we're going to say 3 times 3 will get me to 9 on that denominator. So over here, I don't have to do anything. So sorry, I made a little bit of a mistake here. That should be 2 over 3. So you'll see what I mean in just a moment if you're confused a little bit. So I'm looking for a way to make the denominators the same. You could simply multiply 3 times 3 on the bottom to get those denominators the same. If you do one thing to the bottom, you also have to do it to the top though. So 6 over 9 plus 1 over 9. 6 over 9 plus, oh, I think I did that wrong earlier. There should be 7 over 9 over here. And I simplify to 7 over 9 here. Okay? Yeah. Let's look at the next one. Denominators are the same, so I have 1 minus 4 over x. This equals negative 3 over x, or you could write it as negative 3 over x, where the negative's out in front. Okay? For the next one, not so lucky, not so fortunate, we need to multiply over here to create that greatest common multiple, 5 over 5. This is 5 over 5 times the original portion, 1 over x, minus the x goes over here, minus 3 over 5 times x over x. We're going to simplify that. We get 5 times 1 is 5. 5 times x is 5x's, minus 3 times x is 3x over 5x's. Simplify, we just put them together. 5 minus 3x divided by 5x is the simplified version of this fraction. And I'm just going to circle my answer from before. For x plus 9, x plus 3, the denominators are the same. So I'm going to have 4 over x plus 9. Now we got to be careful when there's a negative in front, because if we bring it out, if we're putting these two numerators together, that means this negative distributes to x, it becomes negative x, and then it distributes to the 3, because there's two terms for this expression. This equals, the x's cancel, and I'm left with 6 over 4, or literally 3 over 2 in the simplified version. For the next one, the denominators are the same, so I have 3x minus 4. And remember to distribute the negative here to the numerator. Combine my denominators. We have 3x, and negative 4 minus 9 is negative 13 over 2. Here's my simplified answer. For the last one, denominators are the same, so 4x minus 7 on the bottom, and then 3x plus 2, and it's positive in between, so I can just literally write it as it is, plus 1x minus 5. Combining my like terms, I get 4x minus 7 as my denominator, but on the top in my numerator, 3x plus 1x is 4x. 2 minus 5 is negative 3. Here is my final answer. Next one, we have denominators being the same. So 3 minus 9x, 3 minus 9. I don't know where I'm getting x from. And I get equals negative 6 over 2x. You do need to simplify these numbers. So how many 2's are in 6? You have 3 of them, and you're just left with x on the bottom. So this cancels to 3, and you're left with with x on the bottom. Look at the last one. This equals x plus 1 over x squared minus 8 minus 7x's. So I want you to be very careful here, because this is a special case. You need to put these polynomials in standard form and then factor to make sure you don't have to cancel anything out. So I have x squared. My next x term is negative 7x minus 8 over x plus 1. So I'm looking for two numbers to factor here. Two numbers, they multiply to negative 8. They add up to negative 7. So that would be 1 and 8, or 1 and negative 8 to give me negative 7. This equals x plus 1 times x minus 8 over x plus 1, and it simplifies. You have to be cautious. You have to be careful and make sure that you're checking to see whether or not these polynomials can be factored when you're doing this work. Now, we are going to get the practice with finding the least common denominators here, and you have a quiz review, but factors to find the least common denominators. So the least common denominator will include at least one of each factor found in the denominators. You've already done this. We've already practiced this. So we're going to rewrite the expressions so the denominator equals the lowest common denominator, and then we're going to add or subtract and simplify. Don't forget number 5, simplify our expressions. Okay, so we've already done this. So because we've already done this, it's not going to be as hard. One of the things you're going to also have to be able to do is to distribute. You're also going to have to be able to do is to factor polynomials. So we want a common denominator for number 1. So 4 is going to go over here, and we're going to end up with 4 over 4 times our original rational, x over 3. And then 3 goes over here, plus 3 over 3 times our original rational on the right. So simplifying, I have 4x divided by 12 plus. Now, I do have to distribute to 3. So 3 distributes to x first. I get 3x. Then 3 distributes to negative 3, and I get negative 9 over 12. Simplifying, I push these together because the denominators are the same. I get 4x's plus 3x's minus 9. This equals 7x's minus 9 divided by 12. Final answer. Next, looking at what we have here. So you could have yourself do a lot of extra work. If we're just looking at this portion on the bottom, how do I get those two to be the same? If you're good with distributing and factoring, you'll see that you can cut out a lot of work here. So if I wanted these to be the same, all I would need to do is multiply the right by 2. Because 2 times x equals 2x, plus 2 times 2 is 4. So I want you to look at what I'm saying here. If you could see that this equals, if you're good with the greatest common factor by now, 2x plus 4, if you break it down into factors, it also equals x plus 2. This is where factoring, being able to factor, comes in handy. It makes it easier to simplify and work with these types of functions. So what I'm going to do is I'm going to rewrite this a little bit and go with what I have here. So I have x over 2 parentheses x plus 2. And then on the right, I have minus 3 times 2 over 2 times x plus 2. And if you look, you can see the denominators are the same when they're in a factor form. All I need to do is simplify. This is a good example of why factoring is important. This equals x minus 6 over 2 parentheses x plus 2. Simplify, this equals x minus 6 over 2x plus 4. Factoring is very important. Now, what about the third one? Well, I have n minus 5, so I'm going to multiply that times both that first rational. So this equals, I'm going to rewrite it over here, n minus 5 times over n minus 5 times n over n plus 2. Next, I'm just going to bring that down over here to the left so I can work with that. Alright, I'm going to make it a little bit smaller. Alright, next I'm going to work with this one. I'm going to move it in a second, but first I have n plus 2 over n plus 2 times 3 over n minus 5, right? So my goal here is to make denominators the same. So make sure I put my symbol in front. That's a positive right there. That's a positive. Okay. Now, I'm not going to touch the bottom portion yet. I am going to work with the top. So for the top, n distributes to n. This becomes n squared minus n distributes to negative 5 n's. On the other side, so plus 3 distributes to n, becoming 3n's. Then 3 distributes to positive 2, becoming positive 6. On the bottom, now let's focus on the bottom here. So what happens here? So n distributes to n minus 5. So I have n times n minus 5. And then 2 distributes to n minus 5. So positive 2 distributes to n minus 5. So I don't have to worry about that part because they're going to be combined. All right. This equals n squared minus, these are like terms, negative 2n's plus 6. It's going to do the distribution on the bottom. N squared minus 5n's on the bottom. On the left, on the right, 2n plus 2n minus 10. 2 times negative 5 is 10. Gonna combine like terms to simplify a little bit and make sure that I can't factor. So this equals n, if I factored this, I can't, n squared plus minus 2n's. So I'm going to write it out. N squared minus 2n's plus 6 is my numerator. On the bottom, n squared. This goes away, becomes negative 3n's minus 10. And I can't factor the top. I could factor the bottom, but it's not going to do me any good. So that's my final answer. Okay. Next. So I'm going to factor out polynomials going forward. Going to factor out your goal before you get started. You're going to factor out any polynomials going forward. So factoring this out, I have x over x plus 2. This is a difference of 2 squareds. Difference of 2 squares. So x over x plus 2 times x minus 2. Okay? Minus 2 over x minus 2. So what I'm going to do, I already made you go around the world to do a lot of work to be able to look at how I can make these denominators create a lowest common multiple. So what doesn't one side have that another does? So things that are the same, x minus 2 is the same for both denominators. Things that are not the same is x plus 2. That means for x plus 2, I need to multiply it on the right rational, the right fraction, the right side of the fraction. I don't have to do anything to x over x squared minus 4 because x minus 2 is already in that rational. It's already a part of the denominator. So that's going to leave me in a situation where I have x over x plus 2, parentheses, x minus 2, right? But on the right, I have negative 2 over x minus 2. And what I'm lacking is the x plus 2 at the bottom. So I create the fraction so that what I do to the bottom, I do it to the top. All right? So the only thing that should be changing here is the right side of this rational. That leaves me with x over x plus 2 times x minus 2. And on the right, I have to distribute, so negative 2x, make this a negative here. Negatives in front of the line going through. And 2 times 2 is positive 4. So you be careful not to distribute that negative yet until you combine the denominators. On the bottom, I have x minus 2. You see the parentheses came on board. You have to put parentheses here around both expressions, times x plus 2. And I don't have to worry about simplifying or distributing here because I already know what it combines to be, unless you want to do the work, okay? But all I have to do is combine the stuff at the top and then worry about anything canceling. So I have x minus 2x at the top in the numerator minus 4. Don't forget to distribute at this point the negative when you're combining two numerators over the same denominator. I have x plus 2 parentheses x minus 2. This simplifies to, that goes away, becomes negative 1x minus 4. On the bottom, you could write that in factored form, but I'm going to revert back to the polynomial that it is, which is x squared minus 4. And that's my final answer. Okay? At the top here, the next one, like I said before, we need to factor these polynomials if we can. So for this one, this is y over, I can factor out a 3 from 3y plus 9. 3 divided by 3y divided by 3 is just y, plus 9 divided by 3 is 3. On the right, minus 3. Okay, looks like I can factor a y out of both terms for y squared plus 3y's. Y squared divided by y is just y, plus 3y divided by y is 3. Okay. Now, what is the same and what do I have to change? Well, this is the same. So that means what I'm going to do to the right is multiply a 3 times a 3 on both sides. I need to get a 3 on that side in the denominator, so I do it to the top as well. So I need a y in the left denominator, so I'm going to multiply over here y over y. Okay? And that should get me to where I want to be. So what does that mean? What does that look like? Well, on the right, y times y is y squared. Okay? And that means I have 3y times y plus 3. Okay? On the left, 3 times 3 is 9. Okay? 3 times y is 3y times the quantity of y plus 3. Now I'm going to keep that in factored form for my own purposes at this point, and I'm going to keep going. Combining the numerators, I have y squared minus 9 over 3y times the quantity of y plus 3. And remember, simplifying is important. We keep it in factor form. This equals y minus 3 times y plus 3 divided by 3y times the quantity of y plus 3. In these expressions, these two quantities cancel, and I'm left with y minus 3 divided by 3y. It's very, very important that factoring be learned for this unit. number last, not number last, but the last number. Remember, factor the denominators first if possible. So let me make some of this a little bit smaller here. Erase a little bit. Okay, so we have 5x divided by something plus 4 divided by, I can't factor x plus 2, but for the left-hand side, I have x squared minus, that's a 1 in front, 1x minus 6. So I'm looking for two numbers. So they multiply to negative 6, add up to negative 1. So that would be 2 and 3 would fit those that need. But I need negative 1. So 3 minus 2 is negative 1. So my factors here, x minus 3 times x plus 2. Now, once again, we're looking at what's the same, what we don't need to move. What's already in place, x plus 2. But what's not in place is x minus 3 on the right. So I'm going to multiply the right side, the top and the bottom, by x minus 3. Okay? Now, I don't do anything else to the left, so I'm just going to combine 5x, and I can put these together now. X minus 3 on the bottom times x plus 2. And then on the top, I have positive 4 parentheses x minus 3. So I have to do a little bit of distribution here. So this distributes here, and we have 5x, right? Nothing happens to the bottom. But 4 times x is positive 4x's. And then 4 times negative 3 is negative 12. This simplifies to equal 9x's minus 12 over x minus 3 times x plus 2. Now I want to make sure that this is simplified at its best, so I'm going to factor the 9x minus 3. This gives me, I can pull out a 3. That gives me 3x minus 4. So there's not much else I can cancel out here. So I'm just going to leave it as it is and recombine the denominator. This equals 9x minus 12 divided by, if I recombine the denominator, I get x squared, what I started out with up here, x squared minus x minus 6. And there's my final answer. Okay, a lot of work. I would probably go back and look through those again. The next portion that you'll have to be concerned with is being able to prepare for the quiz. And after that, we have the review, and then, one last portion is just solving rational equations, then the review, and then the test. So have a good day. Make sure you're working on your project to be able to turn in